Well, I didn't realize my timer was running out on Screencastify. So here we have to make separate videos. Ready? We have this many drops of that many molecules in a drop of water. And then they tell you that you have 100 drops of water. So you know how much is in one, and then they tell you have a bunch of those things. So this is a multiplication situation. I like the sound of that. A multiplication situation. Now it tells us to write in scientific notation, so we'll just do the work in scientific notation as well. You can also use some reasoning and say, well, this number is just 2 more powers of 10, so you can just add the 2 more powers of 10 on. But I don't want to confuse you, so let's just keep it simple and keep doing it this way. Maybe you'll see those patterns at some point yourself. So this is 1 times 10 to the 1, 2, which is, there you go. And we're going to use commutative and associative, so that's 1.67 times 1. And we'll put the powers of 10 together. And we can multiply those. Obviously, you get 1.67. And, right, 1.67. We do our powers of 10, so we add using product of powers property, and that's 23. Now, we go back to the problem, and it says, how many molecules are in 100 drops of water? So our answer is 1.67 times 10 to the 23rd molecules. Lots of molecules of water in a drop of water. Now let's go to the next one. All right, the speed of light is about that meters per second. The speed of sound is about that meters per second. How many times faster is light than sound? So how many times faster? So what we'll have to do here, I'm going to use a calculator for this division. You'll notice when you probably need to use a calculator because it's really silly to divide these. But anyway, I mean, yeah, how many times faster? So we're using division here. All right, we know that light is faster than sound, so we put the bigger one on top. It's 2.998 times 10 to the 8th and 343. We have to have them both in the same format to be able to deal with. So let's put them both in scientific notation. 2.9. First, the speed of light is already there. And this one, we're going to put the decimal, so we make the first factor in between 1 and 10. And then we make the second factor a power of 10, and it's a power of 2. 10 to the second. Now, we're going to divide. So I'm going to do 2.998 divided by 3.43 on my calculator. I wish, oh, it does say about how many. So I should have been kind of rounding anyway, just to start it off. So if I round this, I would get about 3 times 10 to the second and about 3. There you go. That'll make it easier. No calculator necessary. Just choose round numbers that go into each other evenly. That's a pretty big round to get me from 3.4 to 3, but I'm going to go with it. Now, when we divide our regular integers. It's kind of like using associative property. We get 1. We divide using our quotient of powers property, and that means we're going to subtract those exponents. 8 minus 2. 8 minus 2 is 6. So it's, let's see, how many times faster? It is 1 times 10 to the 6th times faster. The speed of light is. Or you can say 1 and then move the decimal over 1, 2, 3, 4, 5, 6 times. So it's 1 million times faster. 1 million times faster. Wow. All right, I'm going to stop this one and then start a new one.